Hey, okay. Welcome back to the Caribou Data Science channel. This is the evening of Thursday, uh, April the 6th, 2023. Let me know if you can see me, if the camera's actually working. You can actually see me on this on the stream or not. Although if I wasn't on the stream, you probably wouldn't really miss my face that much anyway, right? Anyway, good news tonight. Sort of good news. We're gonna upload the final data. 2019, which brings us up until the very beginning of COVID, okay, because the first COVID cases in the U.S. were reported in January of 2020. So we're going from 2013 up to 2019. So we should be able to see yellow cab rides peak in 2014 or 15, and then begin to decline all the way down to 2019, okay? Before beginning to rebound in 2020, okay? So what we're going to do up here, first of all, let's just come up here, let's just take a look at the current numbers. This is just my data loading tank. So you see, this is a little funky. Why do we have a number for 2001 and 2084 in there? Okay. I can also tell you, from looking at the data the other night, there's also some fares, some rides in there where there was a zero fare. Okay, we know that. So what we're going to do, come over here now, because we're up through 2018. Among other things we're going to do tonight, we're going to add some indexes on our main table for both pickup start time date and the actual start date column itself. Because that should really speed up our date queries, okay? And we'll probably even add some indexes to our date table also. So I think we have a date table, don't we? And as always, once we upload the data to the database, we'll delete the files, and that way save some more hard drive space. So that looks good. Let's save this. We got our connection all done. Let's just come all the way down here then and run this. And while we're here, let's just look up the code to add an index to a Duckdb database. Sure, I'd be happy with Duckdb. Excellent. Look at that. That's done. Excellent. Let's just come up here. And notice what we're doing here is we have the original file up here, Yellow Cab, from sample 01, okay? That's our main table. And over here, rather than overwriting the table, what we're doing is we're appending it onto the existing table, which saves a lot of time. Excellent. So we'll create a couple indexes here. And we'll also go back and recreate the views. Okay, we'll recreate the views also, okay? We can use this basic template because if we have a date table, I think we do. I think we have a table that contains the, well, I think it contains, what does it contain? It certainly contains the date, start date, the year, the month, and the quarter, okay? So, because we're indexing start date, if we index the date field in the date column in the date table, both of those to make those two queries run fast also. Because the original query, as you'll see, which I said, you know, when I said, you know, use the start date between this date and this date, it took 12 minutes for that query to run. I'm predicting it's going to be half once we create the indexes on the primary table, okay? Now here's a question. Yeah, so we're going to go back in and we're going to remove all the extraneous data there, okay? And the question is, will this create the new database? No. If you create a new table from Yellow table using a create table statement, new table will not automatically have the index. You can also, okay. Okay, so we're up to 9. This could, you know, this index could be a really big deal. Okay, it could be a really big deal. And we're up to sample 10 has been uploaded. I'll point out here that this will not be a primary key index because you have multiple because the same date appears multiple times in the column in question. Okay. Okay. Let's come down here now. Run this quick query here. Get our latest numbers. Okay. The only trouble is I don't have any data from 2001. At the earliest, I think I got 2013. Okay. Okay. And the maximum of 229 to 12/31/29. But the good news is we've got 915 million rows of data right now. Okay. So let's close this for the time being. Don't save. So the question: Will indexes on the tables improve the performance of views? That's the question. Let's go over here now. Okay, so we'll come up here. Uh-oh, advanced analytical. Oh, man. Enterprise edition. So there is a, let's go up here. Okay, and again, this simple function here to select the date range, okay, took 12 minutes to run. So we're going to come up here now. We're going to create those indexes. We'll save this also. Now this could take a few seconds. It's again where we're actually indexing a pretty doggone big data set. Okay. Our program. But I think, unless I'm mistaken, I made a table that contains, I made a date table, unless I'm mistaken. You can see this is slowing everything down, right? So is the is the free version, is it like a Duckdb Lite or something like that? You wonder what the advanced analytic features that the enterprise level has. So you can see here, this started at 221. Well, that's the amount of time it took to actually run the use command. Now, now I think I should only have to run this once, okay? And here's the thing about ChatGPT. You can see here. I'm asking really pretty simple questions, but yes, if you create a view based on no. Oh man. Okay. So that answers this question. Oh, but you can apparently run one command. Let's save this. So almost 300 seconds now, which is what? Almost, well, if it's 600 seconds, it'd be what? Yeah, we could be here a while. While we're here, let's just go back over here. Let's just look at the let's just look at the blog. And yes, I am on the server. Okay, this is 12/31/23. I got UPy SQL plotting. There we go. Let's see something here. Hmm. There is a large volume of literature about scaling data pipelines. Use Kafka, build the lakehouse, don't build the lakehouse, use Snowflake, don't use Snowflake, use XYZ. However, with advances in hardware and rapid maturation of data, maturation means as the software continues to mature, more stable. Okay, yes. However, the advances in hardware and the rapid maturation of data software, There is a simpler approach. This article will light up the path to the highly but I wonder if it'll rebuild the index. I wonder if it'll be faster. Remind me to rebuild the index during the day tomorrow. Oh, the good news is, for right now, all the data we're going to use is already in the database. See, it's still trying to load the numbers over here. Anyway, let's come back over here. Let's see. However, in advanced hardware and the rapid high-performance single-node analytics with MDS in a box open source stack, Beltano, Duckdb, DBT, Apache superset on Windows using Windows subsystem for Linux. There are many options within the MDS. So if you're using another stack to build an MDS in a box, please share with the community motivation. Okay, what is the modern data stack and why use it? The MDS can mean many things, but fortunately, fundamentally, it is a return to using SQL for data transformations by combining multiple best-in-class software tools to form a stack. A typical stack would include at least a tool to extract data from sources and load it into the data warehouse, DBT to transform and analyze that data in a warehouse, and a business intelligence tool. The MDS leverages the accessibility of SQL. Why build a bundled modern data stack on a single machine rather than on multiple machines and on data warehouses? There are many advantages. Simplicity for higher developer productivity, reduce cost by removing the data warehouse, deploy with ease either locally or on-premise in a cloud or all three, eliminate software expenses with a fully free and open source stack. Maintain high performance with modern software like Duckdb, increasingly powerful single node compute things. Achieve self-sufficiency by completely an end-to-end proof of concept on your laptop. Enable development best practices by integrating with the GitHub. Okay. Now, increase adoption of your tools by providing free and self-contained Daxter's, let's see, something here. Example project uses Duckdb for this already. Reach out to Duckdb Twitter, GitHub, and Discord, or the DB stack. Trade-offs. So, it's already been what, 60 seconds? Then the 60 so has it been 10 minutes already so far? Trust me, you'll thank me in the morning once this index gets run. Trade-offs. Let's see. One key component of MDS is an unlimited scalability of compute. How does that align with the MDS in a box approach? Today, cloud computing instances can vertically scale significantly more than in the past. For example, 224 cores and 24 terabytes of data on AWS. Yeah, with 25 terabytes of data, I could probably run Duckdb in memory and load all my data. Not even my data comes close to it. Okay, anyway. Due to this, let's see, okay. Compute horizontal scaling is no longer necessary for many analysis. Also, this MD in a box can be duplicated with ease to as many boxes as needed in partitions by data subject. So, due to this trade-off, this approach is more often is more of an open source analytic stack in a box than a traditional MDS. It sacrifices infinite scale for significant simplification, choosing a problem, building an environment, installing about the 2104 in WSL, upgrade your packages, install Python, clone Git repo, run make build, and then run terminal, create superadmin account for superset. That's interesting. All right. We could be here a while. In this example, Latano pulls together multiple bits and pieces to allow the pipeline to run with a single statement. The first part is the tap extractor, which is to tap spreadsheets anywhere. This tap allows us to get flat filed from various sources. It should be noted that Duckdb can consume directly from flat files, locally and over the network, or SQLite and PostgreSQL databases. However, this tap was chosen to provide a clear example of getting static data into databases that can be easily configured in the file. So here we go. I thought maybe it was because I kept dropping my internet connection on my phone, but I'm not really sure about that either. The thing to notice, let's come back over here now. You would like to think so. You think it would go through and read the index and then just add the index, add the numbers on the bottom. Uh-oh. Now, there are a few ways you can update the index with new data is added to the table. One way is to use the alter table statement to add new data and then rebuild the indexes. Another way to update the index is to create index statement with the concurrency option, which allows the index to be updated while the table is still being used. Oh, that's interesting. Hmm. Although that's interesting. Where did my email address come from? It wasn't part of the original question. So the system does know what your email address is because I certainly didn't enter it. In general, rebuilding an index will typically take less time, especially if the table already has some data. This is because when we build an index, Duckdb will use the existing data in the table and existing index structure to speed up the process. When you create an index for the first time, Duckdb needs to scan the entire table to build the index from scratch, which is consuming for large tables. You can say that again. However, when you rebuild the index, Duckdb only needs to update the index with the new data that has been added. Excellent. That being said, the time it takes to build an index will still depend on various factors. Okay. Yes, it certainly has taken a long time to rebuild this index, isn't it? Hmm. The thing to notice is in this example is that the conditions joining tables are equalities connected with ands. But relational joins can be defined using any Boolean predicate. One common operation in temporal databases is intersecting two state tables. Suppose you want to find the time intervals when each plot was engaged in combat so we can compute combat hours for seniority. Greatest, that's begin, interesting, least, and end. Interesting. It certainly has some interesting functions, doesn't it? Most of which I don't understand. Special joins. Hmm. Hmm. Friendlier. Friendlier. 1,400 seconds so far, close to 1,500. I may have to round. Hopefully this thing will finish before I go to bed about midnight. And now look at user experience. However, SQL is not famous for being user friendly. Well, you know, it's a lot more friendly than, say, Python, okay? Yeah, so this is the one guy on his introductory video on Duckdb that talked about. Let's see something. Aha, so it is in fact multitasking, right? Okay, good. Okay, traditional SQL select queries requires that a requested column be explicitly specified with one notable exception, the star wildcard. Select star allows SQL to return all relevant columns. This adds tremendous flexibility, especially when building up queries on top of one another. However, we are often interested in almost all columns. Yes, okay, there we go. However, we are often interested in exclude statements. So we're going to use all the columns except for Jar Jar Binks and this whatever this word here, Medalonians. Now we can save time repeatedly typing all columns, improve code readability, and return flexibility as an additional columns are added to underlying tables. Now, Duckdb implementation of concepts even handle exclusions from multiple tables with a single statement. Select this from here, right? Exclude Jaja Binks and this one here, and exclude cancellation. Select range. Oh, replace. Now, similarly, we often wish to use all the columns in a table aside from a few simple adjustments. This should also prevent the use of star and require a list of columns, including those that remain unedited. In Duckdb, easily apply changes to a small number of columns with replace movie count plus 3 as movie count, show count times 1000 as show count. Okay, so you're replacing movie count with movie count, and you're replacing show count with show count. Okay, good. This allows view CTEs or subqueries to be built on one another in a highly concise way, while remaining adaptable to new underlying columns. A common cause of repetition in verbose SQL code is the need to specify columns in both select clause and group by clause. In theory, this adds flexibility to SQL, but in practice, it really adds values. Duckdb now offers the group by with all expected when we first learned SQL, just by group by all columns. Select, so it's going to group by all the columns here. No changes to a query can be made in only one place. Instead, now two. Plus, this prevents any mistakes where columns are removed from the select column but not with the group by clause. Now, not only does this dramatically simplify many queries, it also makes the above exclude and replace clauses useful in far more situations. Imagine if we wanted to adjust the above query by no longer considering the level of scum and villainy in each specific cantina. So cantinas boost scum here. Some okay, good. Note that some concise and flexible SQL have many of your group by clauses can be rewritten like this. That's a good point, because you start out. Well, how common is it? How many times you use some add good function, you run a group by, and it says, oh, you forgot to include X, Y, or Z in your group by statement. Okay. You just put group by all. It's going to group by all the functions. Another common cause for repetition in SQL is the order by clause. Duckdb and other RDBMS have previously tackled this issue by allowing queries to specify the number of columns in order by. For example, order by 1, 2, and 3. However, frequently the goal is to order by all columns in the query from left to right. And maintaining that numeric list when adding or subtracting columns can be error prone. We say select age and sum, group by all, and order by age and total civility. 2,000 seconds and counting. We may wind up spending a lot of time waiting for this to finish. Like I say, hopefully it'll finish before I go to bed about midnight. I'll be right back here. Okay, this is particularly useful. If you came in late, basically, hey, by the way, if you are in the background here, thanks so much for taking time off of your day or evening to stop by. Of course, as always, click that bell icon. That would be notified whenever I upload new content or go live. And you'll never miss the live stream that way. If you are in the background, thanks so much, but it'd be really great if you just stop by the chat session and say hi, okay? Just so I know you're there. This is particularly useful when building summaries, as many other client tools automatically sort results in this manner. Duckdb also supports the order by all descending to sort each column in reverse order, and options to specify nulls first or nulls last. I have to say, it does have some interesting functionality to it, doesn't it? Column aliases in where and group by having. 2200 seconds and counting. In many dialects, it's not possible to use aliases defined in a select clause anywhere but in the order by clause of that statement. This commonly leads to verbose CTEs or subqueries in order to utilize these aliases. In Duckdb, a non-aggregate alias in the select clause can be immediately used in the where or group by clause. And aggregate aliases can be used in the having clause. So here we go. Here's your basic. Only Imperial stormtroopers are precise as nope. Turns out that a parsec is a distance of as very speedy. Some mistakes as total oops. From oops, where nope equals 1. Okay. That's kind of nice, and I never thought about that. Because normally you would have to. Is that really true? I mean, you can use an alias on any column. and group by nope very speedy. Having total oops greater than 3, greater than 0. Case insensitivity while matching case. DB allows queries to be case insensitive while maintaining a specific case as data flows into and out of the system. This simplifies queries when Duckdb while ensuring compatibility with external libraries. So, create table Mandalorian as select 1 as this is the way. Select this is the way for Mandalorian. Okay. Friendly error messages. We'll see about that, okay? Regardless of expertise, and despite DB's best efforts to understand our intentions, we will make mistakes in our SQL queries. Many database management systems leave you trying to use the force to detect an error. In Duckdb, if you make a typo on a column or a table name, you receive a helpful suggestion about the most similar name. Not only that, you will receive an arrow that points directly to the offending site. Select star from Star Trek. Table with Star Trek does not exist. Do you mean Star Wars? Okay, good. Don't worry, ducks and duck-themed databases will love some Trek as well. Duckdb's suggestions are even more context-specific. Here receive a suggestion to use the most similar column from the table of query, and so select long ago from Star Wars. Error, binding error. The reference column long ago is not found from the from clause. String slicing. Even as SQL fans, we know that SQL can learn a thing or two from newer language. Using bulky substring functions, you can slice strings in Duckdb using the bracket syntax. As a note, SQL is required to be one index, so that it is a slight difference between other languages, although it keeps Duckdb internally consistent with other DBs. So, I love you, I know. So you're going to say take the first 3 columns. Duckdb provides nested types to allow more flexible data structures than a purely relational model would allow, while retaining high performance. To make them as easy as possible to use, creating a list array or a struct object uses a similar syntax to other. List slicing. Use convenient dot notation to access the value of a specific key in Duckdb struct column. Okay, so it's saying if you, this is expecting to be targeting computer here, okay? So now it's basically going to ignore the trailing comma. For many functions, Duckdb supports multiple names in order to align with the other database systems. After all, ducks are pretty versatile. They can fly, they can swim, and they can walk. Most commonly, Duckdb supports PostgreSQL function names, but many SQLite names are supported, as well as from the SIMs and migrating the workload to Duckdb, function documentation. Are you building a query that joins similar tables? You've often encountered duplicate column names. If the query is the final result, Duckdb will simply return duplicate column names without modifications. However, if the query is used to create a table or nested in a subquery, a common table expression where duplicate columns are forbidden by other datasets, Duckdb will automatically assign new names to the repeated columns to make query prototyping easier. Hmm. Duckdb believes in using specific data types for performance, but attempts to automatically cast between types whenever necessary. For example, when joining between an integer and a var, Duckdb will automatically cast them to be the same type and complete the join successfully. A list of or in expression may also be created with a mixture of types. Interesting. And they will automatically cast as well. Also, int and big int are interchangeable. Thanks to Big T's new storage compression, big int usually doesn't take any more space. So I wonder how I wonder where we are here right now. Okay. There are many other features of Duckdb that makes it easier to analyze data SQL. Duckdb makes working with time easier in many ways, including by accepting multiple different syntaxes from other databases. For interval data types, use specify time. Okay. Duckdb also implements multiple SQL clauses outside of traditional core clauses using the sample clause for quickly selecting random subsets of your data, and a qualify subset that allows filtering of the results of a window function, much like having clause. The distinct on clause allows Duckdb to select unique combinations of subsets of columns in a select data set. Tell you what I'm going to do here, I think. I'm going to take a break, about 15 minutes. We'll come back and we'll check our come back and I'll check the progress of our of our of our of our process. So what am I doing here? I'm trying to index a table with over 800 million rows in it. I probably should have thought of this earlier. But you know what? All the pain and suffering of this process here will all be worth it in the end, because our views and our queries should run much faster. Okay. However, Second Temple interpreters. Well, I all right, folks. I'll tell you what. I don't know how much longer that indexing is going to take. So rather have you sit here and share the blank screen because I can't really do anything as long as the index is running. Instead, I'll bring this to a close. But of course, as always, click that bell icon so be notified whenever I go live. Maybe tomorrow afternoon. You just never know. Okay. Officially, this is my last stream of the week, but you never know. Sometimes I do something, in the afternoon. Okay, including Bible study. Okay. But thanks so much for stopping by. I didn't realize it takes this long to index 800